Okay, so this is 5-5 notes, and this section is called Inequalities in Triangles. This is the last section of the unit. Everybody say woohoo! Y'all can say something. Oh man, who's that? Okay, so we're talking about different relationships in triangles. Remember, this entire unit is about triangles. We've done all of the special segments. We've done the interior angles. We've done exterior angles. We've done triangle proofs. We've done similarity. And now we're doing inequalities. Okay? 3 things you need to know in this section. Okay? First one is theorem 5-10. The longer I'm sorry, Helen. The longer or larger, we'll do it the other way around. The larger angle is opposite the longer side. This word opposite is going to be really important for the next unit, the one we do when we come back from Thanksgiving. So let's talk about it for a second because you need it for this section, and then it's going to be really important in Unit 5. Alright, if I have a triangle, A, B, C. If I am looking at angle A, it is going to be opposite CB. Okay. Obviously, if I'm looking at angle A, it's not going to be one of the sides that touch the angle. It's going to be the one that's on the other side of the triangle from the angle. Okay, so in this picture, if A was my biggest angle, then CB would be my longest side. And that's all this theorem says. Okay? Alright. The other theorem, 5-11, is going to be completely different, not really. Says the longer, I can't write with this pen, the longer side is opposite the larger angle. So it's basically just the opposite of what this one is saying, right? Sorry. Okay. Give y'all a second to write that down. Alright, the longer side is opposite the longer angle. So this is A, B, C, and my side lengths are 6, 7, and 10. What would be the largest angle? Okay, well, you don't have any of the angles labeled, but which one's the longest side? In this case, BC. So which one is the opposite angle? The opposite angle is angle A. So my largest angle would be angle A. Okay. Alright, one more theorem, and these two are the easy ones. This one's one we're going to spend most of the time on. Okay. 5-12. This one has a name called the triangle inequality theorem. Okay. And instead of actually writing out what the theorem says in words, I'm just going to show it to you in a picture. If this is XYZ, what the theorem says is XY plus YZ has to be bigger than XZ. okay, and any other combination of that. Basically, what it's saying is that if I take any two sides of the triangle and add them together, then that is always going to be bigger than the third side. So let me go ahead and put that in words. Any two sides must add to be bigger than the third side. Alright, sounds pretty simple, but the problems are a little harder than you think they'd be. Okay, it just takes a little bit of patience, but once you get used to them, they're not too bad. You can have two different types of examples. Okay, you're going to have the one that gives you three different lengths. So, 3, 7, 8. So you're going to have the ones where it say, is it possible? Is it possible to have a triangle of those three side lengths? Okay, we're going to do two examples here, version A and version B. B is going to be 3, 6, and 10. So is it possible to have side lengths of 3, 7, and 8, or 3, 6, and 10? Let's do this one first. So pick any two sides. Pick the first two. 3 plus 7. Are they bigger than 8? Yes, but we're not done. You have to check all combinations. So we could do 3 and 8. 3 plus 8, is that bigger than 7? Yes. And 7 plus 8, is that bigger than 3? Yes. So in this case, since we got 3 check marks, your answer would be yes, it's possible. But let's look at this one. Okay. Start with 6 and 10. 6 plus 10 is bigger than 3. Yes. 3 plus 10 is bigger than 6. Yes. And is 3 plus 6 bigger than 10? No, because that's 9. So this one is not. Okay, so you just have to check to make sure all two sides add up to be bigger than the third. And in all reality, some of you that have a whole bunch of logical reasoning probably figured it out that you really only have to check the two smallest numbers to make sure that they add up to be bigger than the third. Okay? If you take the two smallest ones, that'll save you a little bit of time. But if you're not sure, just check all of them. Okay? Alright, then you're going to have another type of problem. Okay? Okay, this is the other type of problem. Gives you two of the sides and asks for the third, but the third could be any range of stuff. So you have to tell me what the range is. Okay, it can't just be anything, but there is a range of numbers that will fit into this possible situation. So our sides are 3, 12, and x, right? And it has to fit this scenario. So one possible combination would be 3 plus x must be bigger than 12. That's like an algebra problem. It's just got a bigger sign than an equal sign. You can still solve it. Minus 3, x should be bigger than 9. That's not the only possibility that we have, though. Possibility number 2 could be 12 plus x is bigger than 3. Okay? Well, this one's a little silly because when you solve this, you get x must be bigger than 3 minus 12 should be negative 9. So we have to be bigger than negative 9. Well, if we have to be bigger than 9, then it kind of makes sense that you have to be bigger than negative 9. And your third possibility is 3 plus 12 must be bigger than x. So that's 15 must be bigger than x, or x must be less than 15. If you're going to switch the order, you have to switch the sign. Okay? Now, since I don't want to start a new page, I'm going to come over here and show you how to graph this. To figure out the range, you need to graph it. Some of you might be able to figure this out just kind of thinking about it logically. But if you graph these out on a number line, so there's -9, there's 0, there's 9, and there's 15. Okay? Oh, thank you. Okay. Alright, so again, I did the math. Sorry I didn't have the page on there, so let me go through this again. First possibility, I put the X here. Second possibility, I put the X here. Third possibility, I put the X here. So I just did all three different possibilities of where the X could fall, and I solved all three of them. Now I'm going to make a number line, and I'm going to plot all three of these. So I have X is bigger than 9. So put a circle on 9, and it should be bigger than 9. X is bigger than -9. Put a circle on -9 and go bigger than. Now X should be less than 15. So I'm going to circle on 15 and go less than. Where all three of them cross is your possible range. Okay? I want to highlight that, but I'm scared it'll smear. This pen really is runny. Okay. So that is your possible ranges, is because that's what was true for all three situations. So your final answer is X should be between 9 and 15. Okay. 12-minute video today.